So we are in lecture 5, and in the first video you took a look at some of these tips that I have for generic tape diagrams, which we've got a little bit of experience with. And now we're going to tackle some of the examples that tend to be a little bit tricky. And usually these fall into one of 3 categories. Either it has to do with time, and the way that they describe the different parts of a section of time can get a little tricky, and that's what's going on in the first one. We also have some things where they will give you information sequentially, like this happens first, this happens second. And then they'll start mixing and matching things together. There's a lot of information to be processed. And some of it might be given together as opposed to individually. So those are the types of things that we're going to tackle in this section. So we're going to start out right here with one that's involving time. So while riding the train from Chicago to New York, Pat fell asleep after traveling half of the trip. When she woke up, she still had to travel 3 times the distance while sleeping. So that's where things get a little bit weird. The way that things are worded can be confusing. Draw a diagram to show the entire trip with the portion that Pat slept darkened. If the trip was 14 hours and began at 7 a.m., what time is it when she woke up? Okay, my suggestion here is before you even get going, let's draw a little schematic of what's happening. So my picture in this one to start is going to say we're starting over here at Chicago. And we're taking the train to New York. And so we're going from here all the way to New York. And we're going to divide this up into different sections. Okay, so it says she fell asleep after traveling half the trip. Well, that one I can figure out. So halfway is here. So in this first section, we know that she's awake, right? So this is awake. And then she falls asleep at the halfway mark, okay? Then at some point she wakes up, and the time left to travel is 3 times that while sleeping. So, and this isn't going to be proportionally correct. We're just making a mark. So at some point she's going to wake up. So falls asleep, wakes up. So during this section right here, she's asleep. And then over here, this is her awake time, right? That's after her sleeping time. So if I'm thinking about darkening something, and we're going to do that part later to show it actually in proportion, but this is where she's sleeping, okay? And the reason that I do this is because the way that this is worded, there's no easy labels here where like, oh, it's A for Abby and B for Bob, right? So we have these 3 different sections. And so what I'm going to do is I'm going to label them with letters. So section A is going to be this one, right? When she's awake at the beginning. And then section B is going to be her asleep time. And then section C is her awake time after. Okay. And we're going to figure out as much as we can about this diagram. So here's what we do next. So what we know is that the trip began at 7 a.m. So over here, we're at Chicago at 7 a.m. And we know that the trip is a total of 14 hours. So 14 hours would be 9 p.m. we're arriving in New York. Okay. Now, the first ratio that's given here tells us that Pat fell asleep after traveling half the trip, right? And so we know that this mark right here is halfway through the trip. Well, if you started at 7 a.m., we know that the whole trip is 14 hours. So if she fell asleep halfway through, that's 7 hours in. And 7 hours after 7 a.m. is going to be 2 p.m. So we know that she falls asleep at 2 p.m. So this is 7 hours. And this is 7 hours. Now, if this is too much in a picture for you, that's okay. You don't have to put all this in here. Okay, but I'm just trying to jot down kind of in a picture what we got going on. Okay. Let's see. Now we identify our second ratio. So let's go in here, and where is that next ratio? When she woke up, she still had to travel 3 times the distance while sleeping. Okay, so I'm going to pull out that ratio, and that is 3 times. So 3 over 1. And let's read that really carefully. When she woke up, she still had to travel 3 times the distance while sleeping. So the first thing that they reference is the time left to travel. And the time left to travel is going to be this last section over here, this green one. And so that's letter C. So that's comparing letter C, section C, to right? So the travel 3 times the distance while sleeping. So it's comparing what she has left to travel to when she was sleeping. And section while she's sleeping is the purple section, section B. So the 3 to 1 is comparing section C to section B. Okay, so drawing out my schematic makes it a little bit easier to label that ratio. And we know that together, from up here in my picture, B and C together have to be 7 hours. So we can use that information to identify what time it is that she falls asleep, or what time it is she wakes up from sleeping. So that's what we're going to do. So we're going to set up our boxes from this. So from this information, we can now set up our boxes. So section C compared to section B, and section C will get 3 boxes, and section B will get 4 boxes. Okay. And then together, those 2 sections, so all 4 boxes, are the second half of the trip. And so that is our 7 hours. And so there's our labeled ratio. Then we want to go to 1 box. So each box then is going to be 7 over 4, which is 1.75 hours. Which if you convert to hours and minutes, that's 1 hour, and 3/4 of an hour would be 45 minutes. So an hour and 45 minutes. So part B then represents that 1 box. So part B, her nap, she took a nice hour and 45-minute nap, which I would love to have. Great. So then, does that answer our question? What are we being asked to find? What time was it when she woke up? So that information is going to give me everything that I need, because we know that the train left at 7 a.m. 7 hours later, right? 5 hours to noon plus 2 more gives us 2 p.m. And then at 2 p.m. she falls asleep for 1 hour and 45 minutes. So we will then know that she wakes up at 3:45 p.m. Okay, so that's going to answer the question that's given. So now if I want a scale drawing here, right? So I want to go back to this beginning part and I want a pretty scaled drawing. I know if I go back here that part C has to be 3 boxes, because that's what's in my diagram, and part B has to be 1 box. So if I draw that down here, let's see, let's color code them a little bit. So part C are these 3 boxes. And then part B is this 1 box right here, right? That one red one. And so that second half of the trip represents 4 boxes. But then that's half the trip. So if there were 4 boxes in the second half, then there also must have been 4 boxes in the first half of the trip. So this would have represented my trip from Chicago to New York. And this one, let me see if I can highlight it. This box would have been the one where she was sleeping, right? And so now you can see the 3 to 1, and you can also have gone from this way and say, oh, now my whole trip is 8 boxes, and that is the whole 14-hour trip. Okay, so that answers the draw diagram picture, the question, and then the question being asked is what time does she wake up, and that's 3:45. So really, to be honest, the trickiest part is identifying this ratio of C to B, okay? And that comes from drawing this little schematic of what's happening. So it seems like a lot going on, but really you're just doing that to isolate that ratio. If you're great at finding that ratio without a big picture, go for it, no problems whatsoever. But if you're having trouble figuring out what you're supposed to label things, then I would draw a picture of what's going on. Imagine that you're on the train and draw a picture of what's happening. That will help you a lot, okay? So that's number 1. Let's go ahead and take a look at number 2. Okay. At some time before the end of the day, there remains 2/3 of what has elapsed since the day began at midnight. Is it before noon or afternoon? Explain how you can tell. Okay. So the first thing we're going to do is we're going to think about these words of elapsed and remains. So the word remains is what's left. So what's left in the day, okay? And the word elapsed, so what has passed. The time that has passed, right? So if those words throw you off, you're thinking what's left in the day compared to what has passed. So before and after kind of thing. So what you're thinking here, if I'm drawing another little picture up here. So this is midnight. And if you're starting at midnight, then the end of the day is also midnight. at some point here, we're going to draw a line and say, okay, here's what time it is now. And the time before that is your elapsed time. And the time after that is what's left in the day. So something in this particular case, you have a ratio of 2 to 3. So let's pull out that ratio. And that's remains, or what is left, compared to what has elapsed, or what is past. So that means I have 2 parts remaining, so after, and 3 parts past. So if you have, the question here is it before noon or after noon? Explain how you can tell. Well, noon's going to be right here in the middle, right? And I want to put my marker down as to where the time is. If I know that there is 3 parts of the day has passed and 2 parts are left, then I know that there is more of the day that has passed than what is left, right? Now, if I'm at noon, what's passed and what's left is equal, right? I'm halfway through the day. But if I have more time that's passed, that means I got to move my marker over this way somewhere. Okay, that way I have more that comes before than what comes after. So this is what time it is. And so then over here, this is what has passed, or your elapsed time. And over here is what is left, or your remaining time. Okay. And so you can see based on my little picture that if more of the day has passed, then it's afternoon. So I don't actually have to calculate anything to go ahead and tell you what the answer is to that one, right? So let me box that solution in for you. So it is afternoon. Okay, now in the next part, the number of hours that have elapsed since the day began is blank times the number of hours that remains. So they're asking you to provide a ratio here of what comes first is elapsed and what comes second is remains. So now I want elapsed on the top and remains on the bottom. So elapsed is my 3 and remains is my 2. So this is going to be 3 halves, or 1.5 times the number of hours that remain until the end of the day. And then lastly, we're going to say, well, what time is it then? Okay. And so what we're going to do is go back up here to our little schematic, and you can see that if, I'm going to try to color coordinate here for you. This is what remains in the day, and this is what elapsed in the day. And together, those 2 things have to be a full day. And so it has to be 24 hours. So that's what we're going to use. So from our ratio here, where we've got R being 2 and E being 3, I'm going to go ahead and draw my boxes. So elapsed time and remaining time. Elapsed will get 3 boxes and remaining will get 2. And then all together, those 5 boxes have to be the whole day. So that's 24 hours. And so now we can divide by 5 to get that each box is equal to, let's see, 24 divided by 5 gives me 4.8 hours. And that's 4 hours. And 0.8 times 60 minutes gives me 48 minutes. Okay, so each box is that much. Now, if I think about the time that's on a clock, our time that's on the clock starts at midnight, right? And it starts counting up the minutes that have passed. So the time on the clock is time that is past, which means that it is your elapsed time. So what I want to do is I want to figure out this time. Actually, I think that was blue before. So elapsed time. So my elapsed time then is 3 boxes. And so if I take my 4.8 times 3, I get 14.4. Okay, so that tells me it's 14 hours since midnight. And then 0.4 times your 60, it gives you 24 minutes. So 12 hours would get you to noon, and then you start over again. So another 2 hours would be 2:24 p.m. or 14:24 if you're thinking military time. Okay. But those are our very typical elapsed and remains type questions. The elapsed and the remains together has to be 24 hours. On to number 3. Number 3, if we read through this one, on Sunday afternoon, Mukti baked cookies and filled the cookie jar. On Monday, she noticed that her family had eaten 1/3 of the cookies in the jar. On Tuesday, da-da-da-da. On Wednesday, da-da-da-da. And then on Thursday, da-da-da-da, right? So I say that because I'm noticing a pattern here in this question. We have something happening on Monday, something happening on Tuesday, then Wednesday, then Thursday. This is something that happens sequentially or chronologically. And so I'm going to do this one slightly differently. Instead of setting up our tape diagram the way we did before, I'm going to use one giant box. And I'm going to shade and divide it appropriately as I go. So I'm going to start with a giant box. And that giant box represents the cookie jar, okay? Because she baked cookies on Sunday afternoon and filled up that cookie jar. So when we start the week, she's got a jar full of cookies. On Monday, so I'm going to color code here. On Monday, she noticed that her family had eaten 1/3 of the cookies in the jar. Okay, so that means I'm going to take my box. I'm going to divide it into 3 sections as best I can. And one of those were eaten on Monday. Okay, so those are my Mondays. So on Monday, they're my yellows. Okay, next. On Tuesday evening, 1/6 of the remaining cookies were gone. Okay, so now my remaining cookies, which is what the fraction is referencing, is the 2 white boxes, right? That's what's left because the yellow ones were eaten. And I need 1 out of 6. But the thing is here that I have 2 boxes and I need to shade 1 out of 6 boxes. So I need to turn my 2 boxes into 6 boxes. Now there are multiple ways that you can do this. You can divide this into 6 sections. We've already cut it vertically, so my next move is to cut it horizontally. You could completely cut this into 6 sections and then highlight one of them. But we could also do it a little more efficiently because we already have 2 boxes. So if I cut my 2 boxes into thirds, then I end up with 6 boxes. Okay, now there is no right strategy. Both of those are totally fine. And then 1 out of those 6 were gone. So 1 of the 6 I'm going to go ahead and highlight as my Tuesdays. Okay, great. Next, let's talk Wednesday. On Wednesday, Mukti's... Whoa, sorry, that was a little much. On Wednesday, Mukti's family ate the same number of cookies as on Monday. Okay. Now, my Monday cookies were yellow. So now, notice also that when I cut the boxes of the white ones, I also cut the yellow ones because I can't have boxes of different sizes because if they have different sizes, then I don't know how to divvy things up properly. So I want to make sure that every single box is the same size. So everything gets cut the same way. So now, instead of having just 1 box for my yellows, I have 3. So for Wednesday, if I want the same number of boxes of cookies eaten, I need to have 3 of those. So we're just going to shade 3 of these. Any 3 that you like for my Wednesdays. Okay, great. On Thursday morning, there were only 6 cookies left. Okay, how many cookies did she make on Sunday? So what's left in my picture are the white ones, right? The white is always the remaining. And so I have 2 boxes remaining. And those 2 boxes have to represent the 8 cookies that are left. So this has to be equal to 8 cookies. Whoops, excuse my handwriting on that one. And then I can go ahead and solve for each box. So 1 box is 4 cookies if we divide both sides by 2 to get an equal ratio. And from there, I want to answer the question. So how many cookies did she make on Sunday? Well, that was to fill the entire jar. And so that's all the boxes on my page. So I have 9 boxes total in my picture. And 9 times 4 would be 36 cookies. So she baked 3 dozen. So she baked 36 cookies as my final answer. Okay. So you could technically do this using the traditional way that we did tape diagrams, like we've done all the others. Have a label for Monday, a label for Tuesday, a label for Wednesday, and try to figure it out. But it gets a little bit complicated because in each case, the fraction is related to what's left from the day before, and that gets a little bit funky. So it's much easier to start with one big box and start cutting it up and assigning pieces. And again, we use this whenever we have things that are presented sequentially. All right, and our last one here, and you excuse my typo here at the beginning. My grammar's a little off. We've got one where they're presenting information, but some things are combined. So let's see if we can sort that out. So Ryan played soccer. So let me just cross these out. For the Lightning, while his friends played for teams called the Thunder and the Tornadoes. During the season, the Lightning and Thunder together won 50% more games than the Tornadoes did. There's a lot in that statement, and we're going to break that down in a second. The Lightning won 1/3 as many games as the Thunder did. The three teams won 20 games total. How many games did each team win? Okay, so there are two things going on here. The first is that the first ratio, first of all, there's three things going on here. Instead of giving you a ratio, they give you 50%. Okay, so 50%, we're going to talk a lot about percents in the next section, but 50% is half, right? So I'm thinking instead of 50%, I'm just immediately going to think half, okay? The second piece that's going on here is that this represents the Lightning and the Thunder compared to the Tornadoes. So notice that Lightning and Thunder together are referenced for the top number. And then the Tornadoes, oh, wait, hold on. Let me assign a different number here. Let's go, that's tricky. Let's go TH. And then the Tornadoes for the bottom, right? The last piece that's going to throw people off here is the word more, okay? Now, we had the distinction way back when that we were either going to use more to represent additive comparison, or we were going to use times as many, right, for multiplicative. This uses both, okay? So it uses both, so it gives us the ratio of one to the next, but the word more means I'm adding them together, okay? So this more means I've got to add the bottom to the top. So what I have to do here, this isn't one value for L and TH. I needed to have one more than what the Tornadoes do, which is 2. So I really need to add a 2 up here. So this is actually going to become 3/2 for the Lightning and the Thunder compared to the Tornadoes. Okay. And that's because the Lightning and the Thunders won as many games as the Tornadoes did. So they won those two that the Tornadoes did, but then they have one more on top. So what you do is you add the bottom number to the top number to get your ratio, and that avoids the more. So the additive comparison means we're adding the numerator and the denominator to become our new ratio. Okay. Now from here, we're going to set up our boxes. I'm going to keep that label together. So I'm going to keep the Lightning and the Thunder together. We'll use the other ratio to separate them in a little bit. And they're going to get 3 boxes because that's what I have in my ratio. And then the Tornadoes get the 2 boxes. And then we're going to go up here to the last piece of information. And it says that the 3 teams won 20 games total. So all 3 teams, so all of my boxes, so 5 boxes, have to be 20 games. Great. Okay. So then each box, if we divide by 5, gives me 4 games. And that will let me figure out, of course, what we're looking for here, how many games did each team win? So that will automatically tell me that the Tornadoes are 3 boxes, and I know exactly how many games they won, right? So 3 times my ratio would give me 12 games. So I've got them good to go. Okay, now the other one, the Lightning and the Thunder, oh wait, I did that wrong. Let's back the train up. Got my labels wrong. So the Tornado had 2 boxes. And so if I multiply my ratio by 2, I get 8 games for the Tornado. That looks a little bit better. Okay, and then I have the Lightning and the Thunder together, and they have 3 boxes. And so if I triple my ratio of 1 box equals 4 games, that gives me 12 games. And we can see that they do, in fact, when you add them together, give you the 20 games total. Okay. So now I've got the tornado down, but I still haven't figured out separately what the lightning's won versus the thunder. So I'm going to go back and see what I missed. So the piece that I didn't do yet is right here. The lightning won 1/3 as many as thunder. So I'm going to take that ratio down here. I'm going to change colors up a little bit. So we have 1/3, and that is, let's take another peek, lightning to thunder. Okay, so that's lightning on top, thunder on the bottom. And that means that when I draw my picture, lightning gets 1 box and thunder gets 3 boxes. Now, the statement I have right here says that the lightning and thunder together won 12 games. So these now 4 boxes for the 2 teams have to be 12 games. Divide each side by 4, and an equivalent ratio here would be that 1 box is 3 games. And so then that represents the lightning because they had 1 box. And then the thunder would be 3 boxes. And so 3 times 3 would give us 9 games. And so here are your other 2 pieces to give all 3 values that we're looking for. Okay, so this becomes a 2-parter. So you're going to set up 2 different diagrams, one for each ratio. Okay, and don't forget that when you see the word more, that means you're going to add the denominator to the numerator. Okay, to create a new numerator, because more is additive in terms of comparison. And so we kind of separate the lightning and thunder from the tornadoes. And then in the second ratio, we can go ahead and separate the lightning from the thunder. Okay, and that'll give us our answers there.